So it's important then to ensure that your safety factor is above 1. Meaning again that no matter what environment that your lab is in a particular day, you're not going to get below the process tolerance that you're trying to ensure compliance with. Alright, so we're going to now talk about performance verification on your instrumentation to ensure accuracy. There are 3 different portions when it comes to ensuring accuracy on your weighing instrumentation. You have routine testing, which is performed by the end user. You have calibration, which is performed by a service technician normally. And you have what I'm going to call FACT, which stands for Fully Automatic Calibration Technology, which is the operational testing that is done internally on your instruments. When it comes to calibration, that is the evaluation of the overall performance of the balance or scale that is achieved by testing all of the different parameters that I mentioned prior: sensitivity, linearity, non-linearity, eccentricity, etc. Routine testing would be when you're doing your daily spot checks. You take a calibration weight and put it on your instrument, and that calibration weight has a certificate of mistraceability, and you try to see what that weight value is compared to the certificate and if it's within the tolerance that you're trying to achieve. You can also again perform repeatability tests, which would be doing replicate weighings with the same mass, doing a standard deviation to see if that repeatability is within your tolerance. And then you have your internal system of your instrument that is performing an internal adjustment, whether it's based off of a time schedule, or in the case of Mettler-Toledo weighing instrumentation, you can have it set so that it will kick in if there's a difference of temperature of a certain value that you set. So, as you're weighing throughout the year, by making sure that you're getting your instruments properly serviced, by making sure that you're doing adequate routine testing on your instruments, and by allowing your instrumentation to perform its type of internal adjustment that it's capable of, you'll be ensuring that your balances are as accurate as possible throughout the entire lifespan and in between your calibration times. So, calibration by a service technician. The benefits here is that you're going to have the overall performance of your instrumentation tested and figured out by a technician coming to your facility. You're able to determine the actual total uncertainty of measurement of your instrument itself, which will achieve the minimum weight. And you're able to get the necessary documentation to ensure that you're within compliance when an auditor comes. The restrictions here are that there's an unknown status of your scale from the time that the technician leaves your facility to the next time that he's scheduled to come back in. And there's a high cost associated with that if they come to your facility more than they necessarily need to, or if you're trying to do testing on your own internally too often. You also have, with most modern weighing instrumentation, the ability for internal adjustment. This compensates for differences in temperature. Typically speaking, that's what's used as a sensor to determine when the internal adjustment has to kick in. By allowing your instruments to run the internal adjustment, you actually can reduce the cost to your facility, to your company, because you can decrease the necessary need for routine testing. New USP requirements in Chapter 41 and 1251 state that by allowing your instruments to run internal adjustments, you can actually decrease the amount of times that you yourself have to do routine testing. The restrictions here is that these calibration weights that are inside your instruments are not traceable. They're traceable when they're put in during manufacturing, but once they leave the manufacturer's facility, there's no more traceability to them. And there's no determination of repeatability or corner load errors with these particular weights. This are 2 pictures of a Mettler-Toledo balance and what the internal calibration weights look like. So at the end of the production of these instruments, these weights, which have a known value, are placed inside your instrument. That known weight is then inputted into your microprocessor. And whenever that internal adjustment kicks in, the balance is actually adjusting that microprocessor value to these two internal weights. Now, these are basically dummy steel masses inside your weights. And over time, they can oxidize, they can change the actual weight themselves. So it's important to have technicians that have the capability to adjust these. Whatever instrumentation that you're using, the actual manufacturer of them, typically speaking, will be able to go internally into your instruments and recalibrate those calibration weights. As an example, if a Mettler-Toledo technician comes in to calibrate a Mettler-Toledo balance, he will test these internal weights here to see if they're within tolerance, and if they're not, he'll be able to adjust it accordingly. The internal adjustments are great to ensure that throughout the lifespan of your instruments, in between calibrations, that your uncertainty of measurement is at a bare minimum. But they should not be used only as replacement of internal adjustment. They should be used in conjunction with it. The last part here is when it comes to routine testing, which is you guys at your facility. So routine testing allows you to very quickly see the actual accuracy of your balance before you do any important or critical application. And it minimizes the risk by testing at appropriate intervals between your calibration cycles. The restrictions is that you're not testing all the different parameters of uncertainty, and it's usually just to give you a quick check of ensuring that you yourself are in compliance. These also have to be sent out for recalibration at a regular interval. So, risk management. Which check should I perform to effectively test my measuring instruments and to minimize risks? So let's consider the different properties that we went over here quickly. When you have a technician come in, he's going to test all these parameters to establish your total uncertainty of measurement. And I know that we're running out of time here, so what I'm going to do is I'm going to show this last slide, because this is kind of the kicker to put everything together here. This is a graph of your total uncertainty of measurement. This black line represents the total uncertainty of measurement that encompasses all four parameters of uncertainty and your nominal parameter of readability. As you can see here, this green line is sensitivity. Sensitivity is closest to the uncertainty of measurement near the capacity of the instrument. What I mean by that is sensitivity has the most effect on your uncertainty of measurement near the capacity. This is why when you do a routine test, you want to test near your capacity. It's common practice to test near where you're actually weighing, let's say 30 milligrams, when in reality, you're be testing right here, which is very far apart from your total uncertainty. Repeatability, which is the red line here, is most dominant on the low end. For this particular instrument, which is 220 gram capacity, once you get below 10 grams, the other three parameters have very little effect on your total uncertainty. Repeatability is essentially your total uncertainty below 5% of your capacity. So when you do routine testing for repeatability, you want to test below 5%. When you do daily spot checks with a calibration weight, you want to test as close to your capacity as possible to ensure that your total uncertainty is being evaluated for. So again, as I stated before, you want to ensure, because of the fact that sensitivity is furthest apart in your capacity, that you use a test weight as close to capacity as possible. Because if you start to do testing at the low end, near where you're weighing your samples or the sample mass, you're not going to be able to actually see if the uncertainty itself is being shown during your testing. So to end it here, it's important again to ensure that all the balances that you use at your facility are appropriate for the particular application that you're using them for. To ensure that you're doing adequate testing and not too much testing as an end user. To ensure that all your documentation is complete for regulatory compliance. And to ensure that you have an overview of all of your weighing devices in all of your different environments of your facility. Mettler-Toledo has the ability to provide you this information through what we call GWP verification, which will give you an overview of all of your weighing instrumentation in your facility, all the uncertainty and measurements of your weighing instrumentation in your facility, and the recommended practices for routine testing for your particular application. If you have any questions when it comes to any industrial application, you can contact Jack Blakely. Here's his email as well as phone number. And for any laboratory applications, you can contact our service specialist for the lab, which is David Cirillo. And with that, I think we will end it here. Any questions?
It's 5 o'clock. Any questions?
Thank you for your time, guys.
Oh, well.